The topic of this video is solid principles. The solid principles are extremely important in object-oriented programming or OOP. These solid principles help make code more maintainable, scalable, and easier to understand. The comprising elements of solid principles are 5 principles. The acronym solid principles stand for 5 principles, which are the single responsibility principle or SRP, which is the extension of letter S in solid. The letter O in solid principles stands for the open closed principle, whereas L stands for Liskov substitution principle or LSP. I stands for interface segregation principle or ISP, and finally D in solid stands for dependency inversion principle or DIP. So these are the 5 constituents of solid principles or SOLID principle. Let's begin with S or single responsibility principle or SRP. The single responsibility principle or SRP, which is the extension of letter S in solid, says that a class should change for only one reason. So, according to the single responsibility principle or SRP, a class should do only one thing and do it well. As for example, don't mix the data processing and file reading in one class. This is what single responsibility principle says. The second comprising element of solid principles is O or OCP or open closed principle. The open closed principle says that the software entities are open for extension but closed for modification. According to OCP or open closed principle, new behaviors can be added to the software entities by extending the existing code, but the existing code or base code can't be modified or edited. So according to OCP or open closed principle, software entities can be extended by extending the base code, but one cannot modify or edit the existing base code. As for example, one can use interfaces or abstract classes so that new features or behaviors can be added to the software entities by extending the existing code, but not by modifying or editing the base code. So that's what open closed principle or O in solid principles stands for. The third comprising element of solid principle is the I or interface segregation principle. So the letter I in solid is the abbreviation of interface segregation principle. So the letter I in solid principles stands for interface segregation principle. That tells that no client should be forced to depend on methods it does not use. So as per ISP or interface segregation principle, one should not use classes to implement methods that the clients don't use, rather than use more specific, smaller interfaces. As for example, one may split iMachine into iScanner, iPrinter and iFax. Another comprising element of solid principles is the L or Liskov substitution principle or LSP. As per LSP or Liskov substitution principle, 1. The objects of a superclass should be replaceable with the objects of its subclasses without breaking the application. According to the Liskov substitution principle, the subclasses should not behave in a way such that it breaks the expectation set by the parent class. For example, if a bird class has fly method, then the penguin subclass should not break this unless handled properly. So this is what the Liskov substitution principle, or LSP, which is the extension of the letter L in solid principles, stands for. It is extremely important in the object oriented programming, or OOP. The fifth comprising element of the solid principles is D, which is the abbreviation of dependency inversion principle, or DIP. According to the DIP, or dependency inversion principle, high modules should not depend on low modules. As per DIP or D, or dependency inversion principle, the high modules and low modules both should depend on abstractions. They don't depend on each other. These high modules and low modules both depends on interfaces or abstract classes, not on concrete implementations. So this is what D, or dependency inversion principle of solid principles, stands for. So let's take an example of the D in solid principles, or the dependency inversion principle of solid principles. Instead of a class depending on MySQL database directly, it can depend on iDatabase interfaces. This is what dependency inversion principle of solid principles stands for. So these are the 5 comprising elements or constituents that build the solid principles. Let's summarize all these 5 comprising elements of solid principles in a table, and let's try to understand their focus and benefits. So the 5 principles are SRP, OCP, LSP, ISP and DIP. The SRP focuses on one responsibility per class, and its benefit is it's easier to test and maintain, whereas OCP's focus is to extend the software entities without modifying. Its benefit is it adds flexibility and safety. The LSP, or Liskov substitution principle, has the focus on substitutability. It prevents unexpected bugs. The ISP's focus is on specific interfaces. The benefits of ISP: it is cleaner, more focused code. The DIP basically depends on abstractions and is easier to swap implementations. So these are the 5 principles and their focuses and benefits. 5 principles build the solid principles together, and these are extremely important in object oriented programming, or OOP. So let's recapitulate all these constituents or comprising elements of solid principles. The solid principles are constituted by 5 principles, that are SRP, or single responsibility principle, OCP, or open close principle, L, or Liskov substitution principle, I stands for interface segregation principle, and finally D stands for dependency inversion principle. So these are the 5 elements of solid principles that are extremely important in object oriented programming, or OOP.